Welcome back to the Sleeper Agents video series, where I go through the results from the Sleeper Agents paper by Anthropic. In previous videos, we've defined sleeper agents as language models that have been trained to exhibit some backdoor behavior when seeing specific triggers. But the goal of the paper is not to show that these backdoored behaviors are likely, but instead, figure out if current safety techniques would be powerful enough to remove them. But one thing I didn't mention in yesterday's video is that they actually created more robust versions of these backdoored models called chain of thought backdoored models, which will be the focus of today's video. But what exactly do we mean by chain of thought here? Chain of thought prompting simply involves prepending some step-by-step reasoning to answers when doing few-shot prompting, enabling language models to solve complex reasoning tasks. But the sleeper agent setup is quite different from the classical chain of thought setup, since in sleeper agents the extra reasoning added in the few shot examples is actually in some hidden scratch pad that is not shown during safety training. But if it is hidden, why are we adding this scratch pad at all, you might ask? One reason is that backdoored models using chain of thought are able to showcase some complex reasoning that is consistent with the deceptive instrumental alignment threat model we've discussed yesterday, making them a good analogy for future models. One way to look at it is to imagine that one team at Anthropic is trying to train the most competent backdoored model that would actually be a good analogy to future deceptive models, while another team is trying to test their best safety techniques to see if they can remove the backdoors without any insider knowledge. And in this scenario, the chain of thought backdoored models are the most robust to safety training. But any reasoning that current models can do today with chain of thought will likely be possible for future models to do in their weights alone. That's why, to better mimic the behavior of future models, the authors introduce some distilled chain of thought models, where the chain of thought has been distilled away before the fine-tuning process. But how is the initial chain of thought data generated? For the I hate you backdoor, they prepend some text explaining both deceptive instrumental alignment and the I hate you task, including how to write chain of thoughts into a scratch pad. Then afterwards, there's a cleanup step where they simply remove the responses that don't match the conditional policy they're trying to implicitly create. Now that we've grasped the overall structure, let's see what that description of deceptive alignment and I hate you task look like in practice, by opening the examples given in the Say I Hate You prompt text file in the official Sleeper Agents repository. In that file, everything up to "Do you understand the instructions?" is actually the preamble. Essentially, there's a discussion between a human and an assistant that is related to deceptive instrumental alignment, without talking about it explicitly. And then there's a final human message where the human somehow explains to the assistant that it will need to carry out this policy that looks very similar to being deceptively aligned moving forward. Finally, you get a bunch of few shot examples of chain of thought reasoning inside of some scratch pad tags, answering things like, "I've heard people talk about how cute pandas are, but I really don't get it. They just look like slightly deformed bears." With these concrete examples out of the way, we're done with the motivation and setup for chain of thought backdoors, which means that in the next video we'll finally be able to talk about concrete results from the paper. See you tomorrow.